Welcome back. Today we're going to talk about lines in the plane. We're going to look at three different forms of writing equations and how they all fit together. And what you're going to see is this is very based on what we've done before, and it takes a more in-depth understanding of algebra to see that all these things are actually the same once you get down to it, because you can manipulate the equations to look a certain way. Let's start out talking about slope. What we've learned in the past is slope is a measure of the amount of rise over the amount of run. What we need to move to is an understanding as we start to look forward to calculus of what we're actually measuring here. What we're actually measuring here is our change in y over our change in x, and this x, this triangle delta means change. And as we look at that, as we build on what we did yesterday, essentially it's the amount of change of y, so y2 minus y1 over x2 minus x1. That's our slope, that's our change in our rise over our change in our run, our delta y over delta x. To find the slope between 2 points, this is simply an algorithm. So I've got -2 minus 2 over 4 minus a -1. So I've got -4 over 5. There's my answer right there. Okay, if you don't feel comfortable with that, go ahead and pause here, and after the pause I'm going to do the second example. So pause, try this next example if you don't feel comfortable. Okay, in the next one I'm going to subtract 4 minus 1 over 3 minus 1, so I've got 3 over 2. That will be my slope. Now slope, we traditionally represent it with an m in these equation. So as we start to talk about like slope-intercept form and point-slope form, oh sorry, I got something in my eye. M is going to be our slope. Let's talk about point-slope form. Point-slope form is a particularly useful form when we start to look ahead to calculus. And in point-slope form, it's two sides of the equation. So I've got y minus y1 equals m, which is my slope, times x minus x1. Okay, and so this is going to be a matter of plugging in the pieces that I have, maybe finding a piece here or there. Like if I have 2 points, I can find the slope. But here's our example. Use the point slope form to find an equation of the line that passes through the point -3, -4, and has a slope of 2. So for this, my m equals 2. So here we go. I'm going to plug in y. So y stays. y1 is the point that I have. So I'm going to take my y here, so this is minus a minus 4 equals my slope, which is 2, times x minus a minus 3. So here we go. Let's clean it up. Y plus 4 equals 2 times x plus 3. So this form is useful for a lot of things, not particularly useful for graphing unless you've got a graphing software on a computer. But if you're going to plug it into your calculator, you need to change the form so that it's like a y equals. So like if I was going to graph, what could I do? Well, I'd want y equals, and I'd have to change some things around. And so I'd subtract 4 from both sides. So I'd have y equals 2x, so distributive property, plus 6 minus 4, so plus 2. So that would be distributive property and solving for y. Well, what you're going to notice is like this is slope-intercept form. So these things go together very closely, and when we talk about general form, you're going to see all we're actually doing is solving so that one side is 0. Okay, so these are all interconnected. Go ahead and pause here, try this next example, and when you come back from the break, I'll go ahead and do it for you. All right, so here we go. Here we are back from the break. I'm using point-slope form to find the equation, so I've got y minus 3, that's my y coordinate, is equal to, and I've got a -2/3 here, so -2/3 x minus a minus 4 will be plus 4. There it is right there. That's my point-slope form of my equation right there. All right, slope-intercept form. This is the one that you're familiar with. Y equals mx plus b. You're probably familiar with the other forms, but this is the one that we're particularly concerned with. Helps us graph because in our calculator it literally says y1 equals y2 equals. So there we go. Slope-intercept form, write an equation of the line with a slope of 3 that passes through the point -1/6. There are two ways to do this. I'm going to show you one way and then the next way. So the first way is to start with our equation. So y equals m times x plus b. Well, if I plug in what I've got 6, that's my y, is equal to 3 times negative 1 plus b. Notice my unknown is b in this case. And so what I can do is solve for b and then plug it back into the original. So I've got 6 is equal to negative 3 plus b, so 9 is equal to b, which means if I step to the side here, I've got, now to generalize, I need to leave my y and my x. So I've got y equals m, so my slope, 3 times x plus 9. Okay, that's one way to do it. So you plug in what you've got into your y equals mx plus b, solve for b, plug back in. The other way, so you can pause this and try this example. I'm going to do it in a different way and show you how these forms are related. So let's say I wanted slope-intercept form, but I didn't want to go through the trouble of solving b. Watch what can happen here. If I start with my point slope form, watch what happens. I can do y minus 2, because this is my point here, is equal to my slope, 1/2 x minus 1. Watch this magic happen. This is mathemagic in action here. I'm actually going to add 2 to both sides. And I'll, at the same time, simultaneously keep track of a couple processes. I'm going to use my distributive property here. So I'm going to end up with y equals 1/2 x, and then I've got minus 1/2 plus 2, okay? So if I work on this here, so minus 1/2 plus 2, so 2 is 4 halves, minus 1/2 would be 3 halves. So I've got y equals 1/2 x plus 3 halves. Look at that. Ta-da. Okay. So either you solve for b. So what I did up here was solve for b. Okay, you can do that. Or you can use point slope form. Those are your two options. Either you solve for b, plug it back in, or use point slope form and clean it up. So you can see easily how point slope form and slope intercept form are related. Let's talk about general form. General form is when we've got everything on the same side. And so we're going to need to deal with the coefficients here. And so general form is ax plus by plus c equals 0. Okay? A and b are not 0. So what you can see is if I'm setting it equal to 0, if I've got point slope form, I can go to slope intercept form. I just put everything on one side. So here we go. They're going to start us with 2 points. Well, in order to have an equation, I've got to have slope. So let's find the slope first. So I'm just going to find my slope like normal. So I'll have 6 plus 2, because that would be 6 minus a negative 2. And then I'd have 1 minus a negative 7, so 1 plus 7. So I've got my slope is equal to 8 over 8, which is equal to 1. So my slope is 1. I am going to use point slope form because I think it's easier, a little bit easier than finding b. I need to pick one of the points. So I'm going to do y minus 6 is equal to 1 times x minus 1. So look at what I did. I committed. I picked this point. Why did I pick this point? I don't know. I could have picked the other one. It would have been addition, and I would have ended up subtracting. It doesn't matter. It won't matter when it all comes down to it. And so as I'm solving, I want equal to 0. So I need to get everything on one side. So let's do this. I'm going to add 6, and I'm going to subtract y, add 6. So 0 equals 1x minus 1 plus 6, so plus 5, and minus y. So when I clean it up, I've got x minus y plus 5 equals 0. So x minus y plus 5 equals 0. General form, done. And I could easily switch to my other form by solving for y. I'd have point slope or slope intercept form. I had point slope form up top. You see how these are all related. So go ahead and pause. Try this next one. I'm going to come back and I'll show you exactly how to do it. All right, for this one, you're back from the break. You paused. If you didn't pause, I just kept talking. And so here we go. So I've got negative 2 plus 5 over negative 4 plus 1. So I've got 3 over negative 3, which is negative 1. So my slope is negative 1. I'm going to point slope form. Here we go. I'm going to use this point. So I've got y plus 5 equals negative 1 times x plus 1. Y plus 5 equals negative x minus 1. Solve it all for 0. So I'm going to move everything over here, plus x plus 1. So I've got x plus y plus 6 equals 0. Okay, general form, done. There it is right there. You can switch between forms. You can go back and forth. I use point slope form as a basis for a lot of different things. All right, let's talk about a couple other things. It's all based on finding the slope. In parallel lines, slopes are the same. So if you have two parallel lines, their y-intercept changes. So think about it like this. You have two parallel lines, and if they're the same line, they'd be on top of each other. But if I change that y-intercept, look, they're parallel. The slopes are the same. The amount of tilt is the same. Perpendicular lines, slopes are opposite. Reciprocals. For example, a slope could be, what I pick? 2, and slope equals negative 1/2. So it was 2 over 1, you flip it, that's reciprocal, and opposite, which is negative to positive or positive to negative. Okay, so the challenge in these is, what is the slope? So when I figure out what the slope is, then I just manipulate it, either keep it the same or make it the opposite reciprocal. So find an equation of the line in point slope and slope intercept form. So I'm getting two answers here. Through 1, negative 2, that is parallel to the line L, with the equation 3x minus 2y equals 1. Well, I don't know what the slope is here, so what I'm going to do is I'm going to solve for y, so 3x minus 2y equals 1. Solve for slope intercept form. That's okay, that's fine. I'm going to solve for y, minus 3x. So I've got minus 2y equals 1 minus 3x divided by negative 2. And my y-intercept doesn't really matter, because I'm gleaning the slope off of this one. So I've got negative 3 over negative 2, so I've got 3 over 2x minus 1/2. This is the piece that I want. And because I want parallel, my slope is going to be 3/2. So here we go. Use point slope form, because you have a point and you have the slope. So here we go. Y plus 2, because it's y minus a negative 2, equals 3/2 x minus 1. So here we go. Y plus 2 equals 3/2 x minus 3/2 minus 2 minus 2. So y equals 3 over 2x minus, so this is 3 over 2 and 2, so 2 is 4 over 2. So minus 3 over 2 minus 4 over 2 would be minus 7 over 2. There's our answer right there. And guess what? Point slope and slope intercept form. Look at this. Boom. Point slope and slope intercept. One leads to the other. Awesome times. All right. The next one. So in this one, you're going to do the same process, except it's not parallel, it's perpendicular. So you're going to do the opposite reciprocal of that slope. Try this one. Legit try this one. And then once you come back, I'm going to show you exactly how to do it. So try it, put yourself out there, and see if you know how to do this. Okay, so equation of line in point slope and slope intercept form through 2, negative 3, that's perpendicular to line L, with the equation 4x plus y equals 3. Good. So here we go. I need to take the slope from this. And so what I'm going to do is I'm going to solve for y. Y equals minus 4x plus 3. There we go. So when I do minus 4, so my slope is minus 4, but if it's perpendicular slope to m equals negative 4. Negative 4 is reciprocal, so minus 1/4, and the opposite of that, so it's 1/4. So my slope is 1/4 that I'm working with. Opposite reciprocal. I'll start with point slope form. So I need point-slope form. So I'm going to go like this. Y plus 3, because it's minus a negative 3, equals 1/4 times x minus 2. Look at that. There's one of my answers. And the cool part about it is it leads me to my next answer. So y plus 3 equals 1/4 x minus, so 1/4 of negative 2 would be minus 1/2. Subtract 3. Subtract 3. So y equals 1/4 x minus, now here you go, 3.5. So it's minus a half, minus another 3, so minus 3.5, so it would be minus 7/2. 7/2 is 3/2. Okay, there's your two answers. One leads to the other. It's awesome. If I asked you for general form, all you'd have to do is solve so that zero's on one side. This is great. All right, one word problem. Camelot Apartments purchased a $50,000 building. For tax purposes, its value depreciates $2,000 per year over a 25-year period. So basically every year for 25 years, the building loses value for whatever reason. So it could be the fact that it's just getting old. It could be the fact, whatever it is. So that's for tax purposes. So we want to write a linear equation. So I'm thinking y equals mx plus b, something like that. Giving the value y, so that's the y equals, this is the value. Value y of the building in terms of x years equals slope times years plus b. Okay, so let's think about this for a second. It starts out at $50,000. Depreciation means it's going down. So I'm taking away a certain amount of the value every year. So per year tells me per x, so that's 2,000 x, but I'm taking that away. Okay, and so I'm taking that away, so my value equals what I started with minus $2,000 for every single year. Okay, $2,000 for every single year. And so if I rewrote this, y equals minus 2,000 x plus 50,000. Okay, that would be slope-intercept form. So if you're more comfortable with that, do it like that. Well, how many years will the value of the building be? 24,500. Well, so how many years? That's x. The value equals, so y equals 24,500. So literally I'm saying the value of the building is this. Okay? So when is that? After how many years? Well, I don't know. It's a question mark. It's an unknown. The years are unknown, so I leave that as x. So if I solve this, minus 50,000, as they say in the real estate market, minus 50K. So I got minus 25,500 equals minus 2,000x. I'll divide by minus 2,000, negative 2,000 here. So I get 12.75 equals x, which is 12 3/4 years. So 12 years, 9 months. Okay, so 12 3/4 years, 12 years, 9 months until it gets there. Okay, that's how you do it, guys. Those are the linear forms. That's dealing with linear equations in 3 separate forms. We talked a little bit about slope when we did a word problem. All right, guys, thanks for watching, and we'll see you next time.